This is the second lecture on vectors, which is from class 12 maths chapter number 10, and in this video I am going to give the complete solution of exercise 10.2. And before watching the video, you have to watch the first video for the concept, in which I have given all the basic concepts required in the whole chapter. And then in the playlist, all the videos are given in chapter wise systematic order. So I am starting with the first question. It is given a like this: I, j, k. You are asked to find the magnitude of the vector. So I'll first find the magnitude of the vector b. Magnitude we represent by modulus sign, and then it is given by under square root square coefficient of I, that is 2 square, coefficient of j minus 7 square plus coefficient of k minus 3 square. So this is how we find the magnitude of a vector. It is sum of square of corresponding sum of square of the coefficients of I, j and k. When the coefficient is negative, we have to keep inside the bracket like this. Then it is 2 square is 4, 7 square 49, 3 square minus 3 square is 9, 58. So it is square root of 62. So this is how we find the magnitude of a vector. Same way we can find the magnitude of vector c, sum of square of coefficients of I, j, k. And here magnitude of a, it is coefficient of I is 1 square, coefficient of j also 1 square, coefficient of k also 1 square. So if we simplify, it is square root of 3. Same way here, magnitude of c, 1 by root 3 square, 1 by root 3 square plus 1 by minus 1 by root 3 under bracket square, and we can simplify. So this is how we find the magnitude of a vector. Then the next is question number 2. The question is, write two different vectors having same magnitude. I'll take any three numbers. I'll take numbers say 2, 3 and say 1. And I'll write a vector A with coefficient of I, j, k having with these numbers, say 2i cap, 2, 3j cap and 1k cap. Now if I write any vector, say another vector B, another vector C, I can write many vectors, say vector D, with these numbers as the coefficient of I, j, k changing in different order. I'll change the order, but I have to keep the numbers same, and with these numbers as the coefficient of I, j, k in different order, I can write many vectors, and all the vectors will have the same magnitude. So I'll change the order for B, say 3i plus 2j plus 1k. So these two vectors, if I find magnitude, will be exactly same. And I can write vector C, changing the order again, I'll bring 1i, then say 2j plus 3k. And even if we take the coefficient negative also, keeping the numbers same, if I take the coefficient negative also, magnitude will be same. So remember, you take any, choose any three numbers, and with these three numbers as coefficient of I, j, k, change the order, and you can write many vectors. All the vectors magnitude will be same. Question number 3, it is to write two different vectors having same direction. Same direction vectors concept is like this. If you take a vector A, and if you want to take another vector B with same direction, then B will be equal to some scalar multiple of A, where lambda is positive. Lambda must be always positive, non-zero scalar. So if I take A is equal to any numbers I can choose, coefficients of I, j, k, say 3i plus 2j plus 1k. And for B, according to this concept, lambda I can take any value. I can take 2, 3, 4, any non-zero fraction, positive. Even I can take integral value, integers, or I can take even fraction also, but I have to take always positive, because the two vectors have same direction. If I take negative, the vector B will have opposite direction. So I can take lambda is 2 into A. So it will be 2 into 3i plus 2j plus 1k. So 2 3 is 6i, 2 4j and 2 1 is 2k. Like this, you can write many vectors in the same direction, but they will have different magnitude. Same direction. Hey, lambda value, any value you can take, any positive value, and you can write hundreds and thousands of vectors like this of same direction. Question number 4, two vectors are given. This is one vector, this is another vector, and it is said that the two vectors are equal, and you are asked to find the values of x and y. So it is given the vectors equal. So xi plus yj, second vector equal to the first vector. I will write like this in this order. And then whenever two vectors equal, remember their corresponding coefficients of I, j, k must be equal. That means x must be equal to 2, and coefficient of y must be equal to coefficient of y. Coefficient of j must be equal to coefficient of j. That means y is equal to 3. So this is very simple question only. Whenever two vectors are equal, remember their corresponding coefficients must be equal. Coefficient of I equal to coefficient of I, coefficient of j equal to coefficient of k, and if k is j, maybe there may be k also, corresponding coefficients must be equal. Then question number 5. 2 points are given. I am marking one point A, the other point I have marked B, and the question is to find the vector with initial point A, this one I am writing A, and the terminal point B. That means vector is from A to B in this direction. I can mark it A to B like this. And the concept given in the first video, whenever 2 points given, it will be the 2 points joining giving two vectors actually, and it is found by like this: second minus first. Second and first we have to see the order in which we have written. So here in the order it is written B is second, minus A is first. So second is minus 5I plus 7j minus the first is 2I plus 1j. And you remember this is also called position vector of second minus position vector of the first. And you keep in mind this points given here, it is in Cartesian form without ijk. And in the question it can be given without ijk or with ijk, it will be having same meaning. It can be given like this also, 2I plus 1j, meaning same actually, but when you do the calculation you must always do in terms of ijk, remember. So if I simplify, minus 5I plus 7j minus 2I minus 1j, minus 5 minus 2 is minus 7I and plus 7, so it is plus 6j. The question is to write the scalar and vector components. So if I write scalar components, are minus 7 and plus 6, only the numbers, minus 7 and 6, these are the scalar components. Now if I say vector components means we have to write in terms of ijk. So vector components are minus 7I cap and 6j cap. So this is the complete solution for the question. Question number 6, it is given like this: 3 vectors, one is A, another B, another C. 3 vectors are given and you are asked to find the sum of the vectors. Sum means we have to just add. So A plus B plus C, this is vector A, this is B, this is C. I have to add the 3 vectors, and addition we have to add the similar terms, I together, J together, K together. Maybe addition, there may be positive addition, or maybe there may be subtraction also, it depends on the sign given. So here you see plus I is 2I minus 2I, it will become 0I, getting cancelled. Minus 2j plus 4j is plus 2j, plus 2 minus 6 is minus 4j, and then k plus 5k is 6k minus 7, so minus 1k. So this is how we add the vectors, add or subtract. Corresponding components we have to add, I with I, j with j, and k with k. So this is how we add the vectors. So this is the complete solution for this question. And then question number 7, it is given to find unit vector in the direction of the given vector. It is like this: one vector A is given, and in the same direction you have to find a vector, another vector in the same direction, another vector whose length is 1. Unit vector means length is 1. That means it is given like this: A cap, unit vector A cap, it is given by vector A divided by its magnitude. This is the formula to find the unit vector. It is given like this: one vector is given, in the same direction you have to find a vector whose length is 1, and this is the formula. So first the vector is given, we will find its magnitude because we need magnitude there. Magnitude is given by coefficient of I 1 square, coefficient of j 1 square, coefficient of k is 2 square. So 4 plus is root over 6, and the unit vector, this is the formula to find the unit vector. It is vector divided by its magnitude. This is the vector I plus j plus 2k divided by its magnitude. Magnitude is square root of 6, and then we can simplify it more. It is 1 by root 6I plus coefficient of j is 1 by again square root 6j and 2 by square root 6k. We can write it in this form. So this is how we find a unit vector in the direction of a given vector. Here A is given, and along the direction of A we are finding a vector. This is the formula. So we got the required unit vector. Question number 8. two points are given, one is P, another is Q, and you are asked to find a unit vector in the direction of PQ along the vector PQ. That means we have to take vector from P to Q, direction from P to Q, and we have learned how to find PQ. It is second minus first. Actually, position vector of second minus position vector of first. And second and first we have to see the here the order in which we have written. Second is Q. So Q position vector is 4, 5, 6. It will be 4i plus 5j plus 6k. Minus first is P. P is 1, 2, 3. So 1i, 2j plus 3k. And then we'll simplify. 4i minus 1i is 3i. 5 minus 2 is again 3j. 6 minus 3 is again 3k. So at first we will find its magnitude. This is the vector PQ we got. Now we are finding its magnitude at first. PQ magnitude, we know it is under square root, coefficient of I 3 square, coefficient of j again 3 square, coefficient of k again 3 square. So if we find, it will be 27 square root. Square root of 27 we can write 9 into 3, that means 3 root over 3. And then required unit vector. We are asked to find the unit vector in the direction of PQ. So unit vector in the direction of PQ is, it will be given by PQ. We can represent like this, PQ cap. Unit vector usually we write like this, PQ cap. It will be vector PQ divided by its magnitude. So PQ vector we have got it here. It is 3i plus 3j plus 3k divided by magnitude is 3 root 3. And then can be simplified more. I can take 3 common, it will be I plus j plus k cap by 3 root 3. 3 is getting cancelled, and you can write whatever is remaining is the required unit vector in the direction of P to Q. Next is question number 9. A is given, B is given, and you are asked to find a unit vector. You are asked to find a unit vector in the direction of A plus B. Whenever we are asked to find unit vector, it is A cap and is found by vector divided by its magnitude. This is how we find the unit vector. And here unit vector along A plus B. So A is given, B is given. In the first step, you have to find A plus B. First vector plus second vector. 2 plus it will become 1i, minus plus it will become 0j, and 2 minus 1 it will become 1k. And we have to find it magnitude at first. Magnitude we know, coefficient of I square, coefficient of j square, coefficient of k square. So it is square root of 2. And unit vector is, this is the formula, vector divided by its magnitude. And here it is, vector is A plus B. So A plus B divided by its magnitude. So A plus B, this is the vector we got, 1i, 0j plus 1k divided by magnitude is square root of 2. So this is the required unit vector in the direction of A plus B. It is always remember, unit vector is vector divided by its magnitude. Maybe it is along A. If it is along A, it is A by magnitude. If it is along B, it is B by magnitude. If it is A plus B, it is A plus B divided by magnitude. So this is how we find the unit vector. And this is the solution for the question number 9. Question number 10. One vector is given and you are asked to find a vector. We are asked to find another vector in the same direction whose magnitude should be 8 units. So the concept is coming from unit vectors. Listen carefully. This is a vector A. And along A, if you find a unit vector means magnitude 1. It is A cap, which is given by vector divided by its magnitude. This is the formula to get the unit vector. Unit vector means magnitude is 1. Now you are asked to find along the same vector, in the same direction, you are asked to find another vector whose magnitude should be 8. This one is magnitude 1. So to make magnitude 8 means we have to just multiply by 8. That means we have to find 8 A cap. We have to find 8 into A cap. And to find A cap is given by vector divided by its magnitude. So at first we have to find the magnitude of the vector. Magnitude is under square root, coefficient of I square, coefficient of j square, coefficient of k square. it is 25 plus 1 plus 4, 29 square root of 30. And then the required vector 8 into a cap, because a cap means magnitude 1, but you need magnitude 8, so multiply by 8 into a cap. So it is 8 into vector is, this is the one given, plus 2k divided by square root of 30. Magnitude a is square root of 30. So this is the required vector. You remember, unit vector means magnitude 1, and you want to make magnitude 8, that's why 8 into a cap. If you want to make magnitude 20, it is 20 into a cap. In general, it is n into a cap, any magnitude n into a cap. You see, if you find the magnitude, n is, say, positive, magnitude of n is n, and magnitude of a cap is n into magnitude of a cap is 1 unit vector. So n, you see, n into a cap, magnitude will be n. So 8 into a cap, magnitude will be 8. So this is the required vector. Question number 11. Two vectors are given. First one I will mark it A, second one I will mark it B, and you are asked to show that these two vectors are collinear. Now first we will see what is collinear concept. Collinear, if two vectors collinear means they are parallel, maybe in same direction, maybe or opposite direction, but parallel. And if one vector is A, another vector is B, collinear condition is A equal to some scalar multiple of B. Lambda is a non-zero scalar, maybe it can be a fraction, positive or negative. A equal to lambda B, or you can say B is some lambda into A. Same concept. We can use any one. In any order we can write. So we have to show that these two vectors are collinear. Now B, I'll first write B here, minus 4i plus 6j minus 8k. Now if I take here minus 2 common, what will be here? 2i minus 3j plus 4k. And you see this is vector A. This is the vector. So minus 2 into A. So see, it is satisfying the condition B is equal to lambda into A, where lambda is minus 2. And therefore the vectors are collinear. And collinear, another condition is there. If we prove cross product equal to 0, then also the vectors are collinear or parallel. We can use this also, or this scalar condition also we can use. Sorry, yes, this vector A equal to lambda B or B equal to lambda A, which we have done here. Either by this, or we can show cross product of two vectors equal to 0. If cross product 0, vectors are collinear or parallel, and even this also vectors are collinear or parallel. Question number 12. To find the given vector, to find the direction cosines of the vector. The given vector, I will mark it A, and at first I will find out the magnitude of the vector. Magnitude is under square root, coefficient of I, that is 1 square, coefficient of j 2 square, coefficient of k 3 square. So it is 1 plus 4 plus 9 square root of 14. The first we will find out the direction ratio. Direction ratio means only the coefficients of I, j, k. Coefficient of I is 1, coefficient of j is 2, coefficient of k 3. So these are the direction ratios of the vector. And direction cosines, only the direction ratio is divided by magnitude. That means 1 by magnitude, 2 by magnitude, and this 3 by magnitude of the vector. So this is how we find direction ratio and direction cosines of a vector. Question number 13. One point is given A, another point is given B, and you are asked to find the direction cosines directed from A to B. Direction cosines of the vector directed from A to B. That means direction is like this, from A to B. This is the AB vector. So we have learned already AB vector, it is given by second minus first. So second, here B is second, position vector is minus 1i minus 2j plus 1k minus first is A is, this is the vector, 1i plus 2j and minus 3k. First we will simplify. It is minus 1 minus 1 minus 2i minus 4j 1 minus plus 4k. So this is the vector from A to B, directed from A to B. It is clearly specified in the question, directed from A to B. So A to B vector we have found. Then its magnitude is found like this: coefficient of I minus 2 square plus coefficient of j square plus coefficient of k square. So it is 4 plus 16 plus 16, 36. It is under square root of 36 is equal to 6. Now direction ratios are only the coefficients of I, j, k. That means -2, -4 and +4. These are the direction ratios of the vector. And we have learned direction cosines will be only the direction ratios divided by magnitude. That means -2 divided by magnitude, -4 divided by magnitude, and 4 by magnitude, and we can cancel and simplify. So this is how we find the direction ratio and direction cosines if the 2 points are given. And remember, whenever points are given, we have the displacement vector. It is found by second minus first. Position vector of second minus position vector of first. You can memorize in short, second minus first. Question number 14. Question number 14. A vector is given. This is the vector. I will mark it A. Say this is the vector, and you are asked to show that it is equally inclined to coordinate axis. Equally inclined means this angle say alpha, this angle say beta, and angle with z say gamma. And we are asked to show that these three angles are equal. That is the question. Now the vector given, it is here I plus j plus k. First I'll find its magnitude. Magnitude we know. Coefficient of I 1 square, coefficient of j also 1 square, coefficient of k also 1 square. It is square root of 3. Now I'll first write the direction ratio. Direction ratio is 1, 1 and 1. And then direction cosines we know. Direction cosines are given by found by direction ratios divided by magnitude. That means it is 1 by magnitude root 3, again 1 by magnitude root 3, and again 1 by magnitude root 3. Now you see the direction cosines are equal. Direction cosines means cos alpha, cos beta, cos gamma. These three angles are equal. And since these three cos alpha, cos beta, cos gamma equal, and hence the angle alpha, beta, gamma are also equal. So you can write the conclusion like this: since the direction cosines are equal, therefore the vector is equally inclined to the coordinate axis. Next, question number 15. It is like this: 2 points are given. 2 points. This is P. I'll mark it represent by vector A. This is point Q. I'll mark it represent by vector B. And so this is the point P. It is given by vector A, represent by vector A, and Q is representing by vector B. And you have to find a point R in between. First step is internally, first part. That means the point R is in between A and B. And ratio given. This ratio we represent by M and N. And ratio given 2:1. That means M value is 2, N value is 1. And internal ratio it is given like this. Point R is given by R is equal to MB plus NA divided by M plus N. This is the formula for finding the point R, which is in between A and B, and it is called internal ratio. It is divided internally. So point R, M value we have 2 into B. B vector is given here, minus I plus J plus K, plus N. N value is here 1 into A. A is this vector, I plus 2j minus k, divided by M plus N is 2 plus 1. We can simplify and get the R. Whatever we get is the position vector of the point R. It is for internally. Now externally, exactly same way. This is say P, this is Q. P is represented by vector A. For Q, position is given by B. And you are asked to find a point R outside. It is externally, outside of A and B. So this will become M, which is 2. And this distance is N, which is 1, and the point R in this case is given by MB minus NA divided by M minus N. Exactly the same formula, only negative here. And all the values you can put, all the values are there. M is there, 2, N is 1, and A and B, all the values are there, vectors. This is A, this is B. You can substitute and you can easily find out. Whatever you get, it will be a vector, and it is the position vector of point R. It is representing the point R. So this is how we find position of a point internally, externally in given ratio. Question number 16. It is given like this: one point is P, another point is Q. P is will represent it by vector A. Vector A, it is 2i, 3j, 4k. We will write in terms of I, j, k. And this will be representing by vector B. A is the vector, position vector, first point, it is 2i plus 3j plus 4k. Second one, position vector, 4i plus 1j minus 2k. And you are asked to find the midpoint between A and B, sorry, yes, P and Q. This is the middle point. And midpoint formula, midpoint, you can just mark it point P is A, and midpoint is given by A plus B divided by 2. A vector is there, it is 2I plus 3J plus 4K plus vector B is also given there. What is the vector? 4I plus J minus 2K divided by 2. We can simplify the numerator, combine. 2 plus 4 is 6I, 3 plus 1 4J, plus 4 minus 2 is plus 2K divided by 2, and you can take 2 common n, cancel with this 2, and you can get the answer. So this is how we find the midpoint. This is the midpoint formula. Midpoint means 2 points are given and you are finding the middle point. Whatever you get, it will be a vector, and it is the position vector of the point P. Question number 17, it is given like this: ABC 3 points whose position vectors are given A, B and C, and the 3 points forming a triangle, and we have to show that the triangle is a right angle triangle. So first we are finding side AB. A to B, like this, AB, we know it is position vector of second minus first. I have found it here AB, and I have found its magnitude also, square root of 35. Magnitude means this length. Same way we are finding BC. B to C, we know it is second minus first. So I have found here BC, position vector of second minus position vector of first, and its magnitude is square root of 41. And the third side is again AC. Same way I have found it is second minus first, and the magnitude is square root of 6. Now these are the three sides. AB magnitude square root of 35, BC is square root of 41, AC is of square root of 6. Now we have to show that it is satisfying Pythagoras theorem. These three sides of triangle satisfying Pythagoras theorem. So smaller 2 I will take it first. AB square, AB magnitude square plus the smaller one again AC magnitude square, and AB is square root of 35 square plus square root of 6 square. Square and root will get cancelled, so it will be 35 plus 6. 35 plus 6 is 41, which can be written as square root of 41 square. That means it is the third side BC square, BC magnitude square. That means, see, AB square plus AC square is equal to BC square, which is the Pythagoras theorem. That means the triangle three sides satisfied the Pythagoras theorem, and therefore we will say the triangle is a right angle triangle. Question number 18, it is given like this: in a triangle, which of the following is not true? We are asked to show in a triangle which of the following is not true. Vector equation. We have the triangle of addition of vectors. Triangle of addition of vector is like this: AB plus BC plus CA is equal to 0 vector. See, we are taking in a specific order. AB along the same order. AB, BC, CA is equal to 0. And one more point we have to know: if we change the order of writing, that means AB, BA, then there will be a negative sign. That means AB is equal to negative of BA. Then we can see which of the following is true. So according to this first condition, it is true. AB plus BC plus CA, it is in specific order. Then AB plus BC and CA, we have changed the order, minus AC, so it is correct. This is also true. CA is equal to minus of AC, so this equation also true. AB plus BC minus AC, AB plus BC minus AC equal to, this is not true, it is false. AB plus BC, it should be plus CA, then it will be the first one. Since it is negative, so it is not matching, this is not true. Then AB plus BC, BC we have changed the order, so minus CB, so it is correct, plus CA, this is also true. So option C is not true. Last question of this exercise is question number 19. It is given two vectors are collinear. See, whenever collinear, we have certain conditions. Collinear means two vectors may be along the same line, in maybe in same direction, maybe in opposite direction, or two vectors may be parallel in the same direction, maybe opposite direction. That is about the collinear. And collinear first condition is A is equal to lambda B, where lambda is a scalar. First condition, A equal to lambda B or B equal to lambda A. Same meaning, B equal to lambda A. We can use first or second. Then if we say unit vector, a unit vector will be plus minus b unit vector. This is also another condition for collinear vectors. And third condition will be respective components of a and b, respective components are proportional. Respective components are proportional. So here you see in the option D it is given option C it is given respective components are not proportional, but collinear respective components must be proportional. So this condition is not true. Since it is written not proportional, so it is not true. If it is proportional, it will be true. Another condition, here it is given vector A equal to vector B. So if it is written like this also, it will be not true. This question, there are some printing mistake in question, some mistakes in answer. So you have to understand this definition. According to this definition only, you have to select the answers. Since it is vector A equal to plus minus vector B, so this is not true. But if I write A cap equal to plus minus B cap, then this will be true. This is the second condition written here. Since it is written vector, difference, here A cap unit vector, here A vector. So A vector plus minus B vector is not true for collinear. A unit vector plus minus B unit vector is true. So if it is given like this, you will say true, and the way it is given, it is not true. And this is true. A is lambda B or B is lambda B. This is true, which we have written here. First condition, A equal to lambda B or B equal to A. Now about the fourth condition, both A and B have same direction. No, collinear may have different direction. It may be like this. It may be like this. Collinear may be along the same line, same direction, maybe different direction. That is the meaning of collinear. Or maybe parallel, same direction or opposite direction. But here it is saying that only same direction. No, it may have different direction. So this is also not true. So this is the solution for this question. So this is the end of this lecture, and in this video I have given the complete solution of exercise 10.2, and in the next video I will give the complete solution of 10.3 and another video for 10.4, and all the video will be available in the playlist in which chapter wise given the videos in order.